Hi, welcome back to the shop. Today we have another small project. A friend of mine wants to scrape the ways of his small Chinese lathe. He has a lathe almost the size like mine. It's about a 9 by 20, but he doesn't have a straight edge for touching or for high spotting the ways. So he asked me if I could machine him one on the shaper. And he sent me this piece of continuous cast iron, or I think Durabar is a manufacturer's name for that stuff. It machines pretty nice and it's pretty stable once machined. So we're going to use this, and he made me up a little drawing. We'll square the block up all around and cut this bevel with 45 degrees onto it. His ways have 60 degrees angle, but with the 45 degrees on the bevel, he will be able to do the 60 degrees and the also common 55 degree ways. We're going to cut this to length on the bandsaw, square it up and cut the bevel. And we're going to put threads on the end so he can screw in two handles. Okay, I set the shaper to about 190 millimeters of stroke, and I put the piece in the vise. It's not clamped down yet. I have again my brass shims to protect the vise from the rough cast surface of the material, and it's resting on two parallels. Now we're going to take a first pass to clean up the surface. Got the first side roughed out. The finish is not too bad. This continuous cast iron gives a pretty good finish and machines very nicely. You saw me running the vacuum cleaner a few times. I do this because of the cast scale. I don't want it all over the machine. And also the cast iron dust, I want to get rid of it, so I'm just using the vacuum cleaner instead of blowing it off or using a brush and having all over the floor. And that's also the reason why I'm using the pull type clapper box, or one of the reasons, to keep the chips from flying all over my shop. And also the cut with this clapper box is way more stable. Okay, I turned the piece around and let the machine surface rest again my fixed jaw. On the other side I have again my brass shim to protect my movable hardened jaw from the rust. And we're going to take another cut. I got all four sides cleaned up. The corners have still the mill scale or casting scale, but it's kind of squared up in parallel. For the application as a straight edge, we only need normally we only need two faces flat and on this desired angle to each other, but just for fun I want it all around to be square and parallel and the same thickness on every spot, just because I don't like to do a half-assed job. So let's change over to the finishing or shear bit and get this thing square. Okay, here is my shear bit with the big radii and the heavily skewed cutting edge, and this is what we're going to use for the finishing. But it needs a minor touch up with a stone. We're just going to hone the edge very lightly. We're using a carborundum stone and just hone the edge very lightly. Okay, we finished the second of the narrow sides, and with the shear bit we got an incredible fine finish. And you can see the chips we're getting. These are real small curly chips, not just dust like you normally would expect from cast iron. And that's because of the geometry of this shear bit. Due to the heavy skewed cutting edge, it really produces a nice curly chip. Even in a brittle material like this would even work in brass. You would get nice stringy curly chips. We cleaned up all four sides with the shear bit, and I checked the thickness on all four corners, and I'm between 23.6 on these both corners and 23.62 these two corners. So we are parallel within 0.02 of a millimeter, and for a absolutely non-critical application, that's perfectly fine. It wouldn't even matter if this surface would be unmachined, but my personal OCD doesn't allow me that, so I'm going with some medium accuracy for this operation. Now we're going to chamfer the edges to get rid of the mill scale. Okay, for chamfering the part, we have to change the clapper box over to the push type clapper box, and to show you, this is a pretty simple and fast process. Remove this top nut, and you go in here with an Allen key, remove the clapper box, clean the mating surfaces, pull out your push type clapper box, clean that also. For cleaning machine surfaces that are going to mate, I prefer my bare hand over a rag. That way you also feel if there is a burr or some material embedded into the surfaces. I don't like the practice of stoning every surface every time you mount it. That way you can alter the accuracy of a surface pretty fast. So I don't like to stone my machine tables every time I drop the vise on or anything like that. I'm going to use this tool, this chamfering bit. Okay, I changed the plan and I'm cutting the bevel before I finish up the ends and cut these threads and do the engraving. So I have it set up on the table with my two Shopmate 123 blocks, clamped it down with 2 clamps, put some brass under it to protect those machine surfaces, and I ran the indicator along the edge to align it with the machine. We're making good progress in cutting the bevel. I'm feeding down by hand, and for every step I go in about 1.5 millimeter. That means I take a 1.5 millimeter wide cut, and with every stroke I take about 1/10 of a millimeter in depth. Okay, I finished cutting the bevel and I teared down the setup, and now you can see the part in cross section. Next I'm going to chamfer this edge lightly to get rid of the excess casting scale. Then we can face off the ends, cut our threads for the handles and do our engraving. And then we're done. Okay, and I just broke the edge of the straight edge to get rid of the mill scale. And now to bust the myth of the stable and non-moving cast iron. After shaping the bevel on this straight edge, it made a nice bow, and I get a movement of plus minus 0.02 of a millimeter on here, so this piece makes a nice bow in that direction. Cast iron has stresses in it like every other material, and if you machine the material it will move on you. There is nothing to it. You can stress relieve it by putting it in an oven, and you can cut down on the stresses, but you can't get rid of all these stresses. There will always be remaining stresses in every material you're using, so you have to deal with it, and in that case I will have to recut the bottom surface. And I will take only a very light pass on the bottom, so the stresses in the part stay equal, and my bevel edge over here, my bevel surface will not warp in the other direction. And when doing something like this, you have to go down from roughing, then you're releasing most of the tension, and then you have going down, take a finish path, release the tension, take another finish pass. Much of it comes down to the material, the geometry of the part. A long, skinny part is way more prone to warping due to stresses than, say, a massive block or a short piece of round material. That's unlikely to warp under the internal stresses. So yeah, keep that in mind when you machine something. Cold rolled material, for example, has an incredible amount of internal stresses due to the cold drawing. And when you machine one side of a flat bar of cold rolled mild steel, it will go banana on you. And the cast iron is way better. It's way more stable, but it will move also. So let's go over to the shaper and fix this. Okay, I decided to not go back to the shaper and do it with the power scraper. Okay, first of all we're going to clean the granite. I'm just using a household cleaner for that application. Something like a window cleaner or even alcohol works pretty good for that application, but I used to have the household cleaner in the shop already, and this is what I'm going to use. Okay, this will not be a scraping tutorial, I'm just going to show you how I do this. I'm using the Dicam High Spot Blue, and for applying the color to the stone I'm going for a two-step process. First I'm spreading it out in an unused area, making it even, and then rolling the area I'm going to use. And you don't need crazy much of that stuff, just a little dabadooya. Then roll it out. And I'm using one of these rollers you get at the art store. I don't know what they are really for, but they work pretty good for applying the blue. And yeah, as you can see, I'm applying the color pretty heavy here because we're really roughing. This is for only a roughing process, so I'm going pretty hard on the color. And now for touching off, we're going to take our workpiece and then we're just going to touch it off. Very light pressure on top and short movement. In my little experience, when you apply too much pressure and you go crazy on the surface plate with the movement, the image you get on this side is not the real image. It gets messed up, and as you can see, we have two areas that are carrying the part or bearing. Okay, this is my Renz power scraper. It's almost like the well-known Biax machines, only that it's made by Renz. I got this machine almost new for a bargain, and yeah, it imitates the movement of hand scraping. The speed is adjustable, and also you can adjust the stroke from, I think, 20 millimeters down to 0 for fine scraping. But today we're just rough scraping. Okay, and here we have our straight edge. I put it in the vise and I laid out or mapped out the two high areas. You don't want just to remove the paint, you really want to get away some material, and I honed the edge of my scraper blade, and now we're going to do a first pass. And that's way too low stroking or stroke. For increasing the stroke, you put this small wrench in here, turn it, and that's more like roughing. That's more like it. But still a bit short on the stroke length. And as you can see, I'm removing quite a lot of material by the scraper. Scraping is sometimes way faster than filing, and the rough scraping produces a lot of burr, so you need to stone the burrs down before you touch up the surface again. You don't need to go crazy with the stone, just clean off the high spots. Okay, we're just respreading the color. I'm not taking new color up with the roller, I'm just spreading out the color that's already there. Now, of course, we got a pretty horrible image on the touch off, but it's already not any more bearing in the center. Now we got this large area and this large area, and some of the minor high spots here. I think we will get this to bear in about 5 roughing paths. Okay, I always like to lay out where I'm going to scrape, especially when I'm roughing. Okay, second path. Again, we're stoning very lightly. Okay, let's touch it off. And as you can see, it starts to bear out here and out here. Next, this is the third pass. Of course, you're alternating your scraping direction every time you do a new pass to get somewhat of an even picture. Okay, I was not way off. This is pass number 8 and we're bearing almost on the whole surface. Now we can start to refine it slightly. I'm going to decrease the stroke on the scraper and start to work a bit more refined. You have to be very careful when you're coming up to an edge. You kind of have to tilt the blade in and be aware that it doesn't grab the edge. Just to be clear, this is still in the extremely rough phase of scraping. But as you can see, now we get a more or less even pattern. There is a slight hollow, there is a bit of a hollow, and there this is a bit hard to read because I'm using pretty much of the high spot blue, and that makes this area a bit, not sure about it, but we're getting there. There we go for number 9. Okay, I'm down at 20 pulses and the surface got somewhat fine. It looks like a scraped surface, not like a butchered surface anymore. And if we hold a straight edge on there, it's pretty darn straight, and we get a it's hard to capture that with the camera. We get a pretty even bearing surface. Okay, this is past 22. I changed to a narrower blade, and I also reduced the stroke of the machine. Okay, I only worked the high spots and I tried to get all of them. This is my 25th path and we're getting to a more or less fine finish. Okay, after the last path I did a touch-off and we get a pretty good surface, and it's flat. It's not bearing very evenly, it's a bit hollow here, but it's very good bearing here and here. At first I didn't plan this as a two-part video, but this is getting pretty long, and I will make at least a two-part video on this, maybe even three parts. So I will end right here. You have seen me machining the straight edge and starting to scrape it. Next time we will finish this surface and start on the bevel surface. I hope this is interesting for you, and let me know in the comments what you think. As a disclaimer, I'm absolutely no professional scraper or machine rebuilder. This is all self-taught, and I have seen, or in person I got shown some of the scraping by Mr. Müller-Nick down in Munich. He showed me some stuff, but most of it is learning by doing, and yeah, that's how I do it. A real machine rebuilder or scraper might wave his hands over his head, but I get results that I can use, and that's fine for me. So yeah, that's how I do it. Anyway, thank you for watching, and see you next time.